Welcome to clickmyproject.com. The project title is Automatic Seizure Detection using Wavelet Transform and SVM in Long-Term Intracranial. The project abstract is a proposed method first conducts wavelet decomposition of multi-channel intracranial with 5 scales and select 3 frequency bands of them for subsequent processing. Effective features are extracted such as relative energy, relative amplitude, coefficient of variations and fluctuation index at the selected scale, and then these features are sent into the support vector machine for training and classification. Our project flow diagram is to reduce the noise from EEG signal by using DWT. It means on discrete wavelet transform. First we have to collect the dataset. In the datasets are our related process. So our EEG signal, it means electroencephalogram signal, going to analyze the brain signal. According to the datasets, we have to read the input of our EEG signal. So after reading our input signal, we are going to remove the external noise to apply the some filtering methods. So next we have to apply the DWT of our input signal, it means discrete wavelet transform. After applying our DWT transform, we are going to apply the ICA, it means on independent component analysis. So after analysis the process, we are going to apply the IWT, it means inverse discrete wavelet transform. Next we have to extract the features by using on wavelet detection. So we are going to detect the corresponding wave to remove the external noise and get back the original signal. Finally, we are measure the performance for accuracy and sensitivity and specificity. The project source code file was run from the command window. In current folder shows some files. So it is our source code files. So in this source code files, they are getting the datasets. So in this dataset, I have separately 3 different type of dataset. First one is migraine, so it is one of the brain datasets. Then second one is normal, it is the one of the brain dataset, and seizure detection, or it is the dataset. So I have collected 3 different type of datasets. Then it is the math file to our process. So our source code file was stored from the main file.m, so we have to run that file. When I run that file, go to datasets. So in the datasets, I have click any one of the datasets. For example, I have clicked the seizure detection, so I will give the, so the process will be going on. So the process was completed. So now we discuss our process. So it is our input EEG signal. So in that signal we are going to analyze whether it is seizure detect or not. So it is our input EEG signal. So in that signal we are going to filter. So when I am using the low pass filter, in X label shows the frequency and Y label shows the power of frequency in decibel. In figure 3 shows the when the brain signal will be affected or seizure. So it is a different wavelets form, it is gamma, beta, alpha and theta. So it is going to analyze our seizure. So after we have to classify by using an CNN, it means convolutional neural network. So when we are going to classify the signal, so it is affected in seizure. So according to that process, the accuracy will be shown on the graph, our proposed method. So it is the accuracy graph. So it is the sensitivity of our process, then it is our specificity of the our process. So finally you have to calculate all those things for accuracy and sensitivity and specificity. These values are shown in the table. When this process, the accuracy value is 83.75%, and then sensitivity is 100% and specificity is 92.3077. So it will be taken as skewness value and kurtosis value and entropy values also shown in the command window. So our variables are discussed with the workspace. So we are going to check the minimum and maximum value of our process, and then signal size and what type of labels are trained. So it is also shown in the workspace. So finally we are discussing the accuracy of our process. So the project demo was completed. Thanks to watching this video.